Lesson 7i, Linear Two-Body Systems with Friction. Like last time, we'll assume the wire is ideal, meaning that it's weightless, static, and unbreakable. When calculating acceleration, we will combine the masses into a single body. But when calculating tension, we will need to separate the masses for those calculations. Also recall that tension in the wire will be the same at both ends of the wire, just in opposite directions. For our first example, we'll be using a 20 kilogram box and a 30 kilogram box joined together by a string. They are being pulled along on a surface with a force of 100 newtons, and the coefficient of friction for both objects will be 0.15. We will calculate acceleration and string tension. Here's a diagram of the bodies and the force applied to the right. The coefficient of friction is 0.15. The forces acting on mass 1 are force gravity and force normal, which balance one another out. The forces on mass 2 are similarly gravity and normal force, which again balance each other out. Now, since the force friction counters motion, we can assume if there's any motion at all, it will be to the right, since the only applied force to the system is to the right. That makes force friction to the left. Friction force can be calculated as coefficient of friction times normal force, or simply mu force normal. In this case, force friction is 0.15 times mass times gravity. Subbing our values in, we have 0.15 times 50 kg times 9.8 newtons per kg. The 50 is the result of the two masses being combined. 20 kg plus 30 kg makes 50 kg. Force friction is therefore 73.5 newtons. Force tension is in the wire, which is equal at both ends of the string but in opposite directions. They have the same magnitude. Let's calculate acceleration. We can begin by ignoring normal force and force gravity for both masses since they cancel one another out. Looking at our bodies, who wins the tug-of-war? Applied force or force friction? Well, applied force wins over force friction as 100 is greater than 73.5. That makes the net force equal to force applied minus force tension plus force tension minus friction force. The force tensions cancel one another out, leaving net force as applied force minus friction force. Net force is 100 minus 73.5, making net force 26.5 newtons. Remember, the formula for net force is mass times acceleration, which for the two bodies is mass 1 plus mass 2 times A. 26.5 equals 20 kg plus 30 kg times acceleration. 26.5 newtons equals 50 kg times A. Isolating A, we get acceleration equals 26.5 divided by 50. Acceleration is 0.53 newtons per kg, or equivalently, acceleration is 0.53 meters per second squared. For tension, we can calculate it using either mass. All calculations will be specific to the one mass, meaning no grouping of the bodies. The one value that will be constant for the individual masses and the masses combined is acceleration, as all of the parts will be moving and accelerating at the same rate and in the same direction. Let's start with mass 1. Who wins a tug-of-war? Tension force or friction force acting on mass 1? Force tension wins as its vector points to the right. The masses move to the right. F net is therefore tension minus force friction. Winner minus loser. Isolating force tension, we get F net plus force friction. Remember, F net is mass times acceleration, while force friction is mu force normal. Force tension equals mass 1 times acceleration plus mu force normal of mass 1. Force tension equals mass 1 times acceleration plus mu mass 1 times gravity. Force tension is 20 times 0.53 plus 0.15 times 20 times 9.8. Force friction on mass 1 is 29.4 newtons. Force tension is therefore 10.6 plus 29.4, which makes 40 newtons. The tension on the string at mass 1 is 40 newtons. Now remember, tension is the same on both ends of the string, so if we use mass 2, we should also get tension of 40 newtons. Well, let's try it. We'll use mass 2 to check. Remember, all of our calculations will be using only mass 2 on its own and not the combined masses of mass 1 and mass 2. Looking at all the forces acting on mass 2, who wins the tug-of-war? Is it applied force, or force tension, or force friction? Well, since the object moves to the right, applied force wins. That makes force net equal to applied force minus force tension and minus force friction. Isolating force tension, we have force applied equals force friction 2 minus force net. Now remember, force friction is mu force normal 2, and force net is mass 2 times acceleration. Therefore, force tension is 100 minus mu force normal 2 minus mass 2 times acceleration. Force normal is mass times gravity. Force tension now is 100 minus mu mass 2 times gravity minus mass 2 times acceleration. Subbing in values, we have force tension equals 100 minus 0.15 times 30 kg times 9.8 minus 30 kg times 0.53 meters per second squared. Force friction 2 works out to be 44.1 newtons. Force tension therefore is 100 minus 44.1 minus 15.9. Force tension is 100 minus 60. Force tension on a string at mass 2 is 40 newtons, which is equivalent to the force tension at mass 1. Notice as well that force friction 1 plus force friction 2, 29.4 plus 44.1,